Hello friends, I am T2 sir. We are here today to discuss probability. We will explore the concepts of conditional, joint and additional probability and Bayes theorem. In simple terms, probability is the likelihood of an event to occur. Single outcome or set of outcomes is called event. Total number of outcomes is called exhaustive events. Probability is measured by the ratio of the favorable outcomes means favorable events to the total number of outcomes means exhaustive events. Probability could also be represented in terms of odds that event A will occur, which is defined as probability of event A divided by 1 minus probability of event A. The odds against the event occurring is reciprocal of the odds that event A will occur. It should be noted that these are just terminologies representing similar information in alternative manner. As a next step, we will now discuss type of events and their probabilities. We will discuss mainly three types of events. First one is not mutually exclusive events. Second one is mutually exclusive events, and the third one is independent events. It should be noted that when two events that can happen at the same time are called not mutually exclusive events, and when two events that cannot happen at the same time are called mutually exclusive events. If occurrence of one event has no influence on the occurrence of other event, then two events are called independent events. Let's understand these concepts with an example. First example is positive annual return on S&P 500 and Apple stock are not mutually exclusive events because both S&P 500 and Apple stock can have positive return at the same time. Apple being one of the constituent of S&P 500 index would obviously have an impact on S&P 500 annual returns, particularly when Apple is the largest constituent of S&P 500. In the same fashion, the second example is of selecting one card from the pack will lead to only one outcome, not another. This is an example of mutually exclusive events because if you select black card of a heart shape, you can't select another card because you need to select only one card. And the final example is throwing of two dices. Outcome of each dice is independent of the other. Therefore, it is an independent event. After discussing type of events, now let's discuss conditional probability. Conditional probability, represented by P event A bar event B, is a probability of one event A occurring given that another event B has occurred. In case of not mutually exclusive events, conditional probability is number of events occurred in the overlapping area A and B divided by number of events under section B. It should be noted that for conditional probability, it is given that event B has occurred. Therefore, number of events happened under section B represent exhaustive events or total number of events. If instead of number of events, probability is given for highlighted area represented by probability AB and probability of section B is given as probability B. In such case, conditional probability is probability of overlapping area A and B divided by probability of event B. Key point to note here. B has already occurred and is on the right side of the bar in the sign representing conditional probability. Now, in the case of mutually exclusive events, in this case, conditional probability is 0 because both events cannot happen in this case. Finally, in the case of independent events, in this case, probability of event A is conditional probability, which is probability of event A occurring given event B has occurred. This is because event A and B are independent. It should be noted, probability of event A given B event has occurred is not equal to probability of event B given A event has occurred. As a next step, joint probability of event A and event B, which is probability of both events occur at the same time. In case of not mutually exclusive events, Joint probability is number of events occurred in the overlapping area A and B divided by total number of events. Kindly note, in this case, we are dividing it by total number of events, not by number of events in B section, as was in the case of conditional probability. We could also calculate joint probability by multiplying conditional probability with probability of event B. Now, in case of mutually exclusive events, joint probability of event A and event B is 0 in this case, as both events can't happen together. Finally, in case of independent events, joint probability of event A and event B is probability of event A multiplied by probability of event B. It should be noted that in this case, event A and event B are independent, but these two events can happen together. For example, getting similar outcome of 5 on both the dices is possible, but these two outcomes are not dependent. It should be noted here that probability of event A and event B occurring together is equal to probability of event B and event A occurring together. Next step is to understand Bayes' theorem, which allows you to update the probability of an event by incorporating new information. This theorem is mathematically represented by adjusting conditional probability and developing relationship between probability of event A given B event has occurred and probability of B given A event has occurred. For example, calculating probability of Apple stock return is positive given that S&P is already up, or probability of S&P 500 return is positive given that Apple stock is already up. In our last section, we will discuss additional probability, which is a probability that at least one of the two events will occur. In case of mutually exclusive event and independent event, additional probability at least one of the two event A or B occur is probability of event A and probability of event B. In case of not mutually exclusive events, overlapping area is getting double counted. Therefore, we need to subtract joint probability of event A and event B, represented by PAB. We are now at the end of our session, but before we close this session, let's go over the key takeaways of our session. First thing, probability is the likelihood of an event to occur. Probability is measured by the ratio of favorable outcome to the total number of outcomes. There are mainly three types of events for which we calculate conditional, joint, and additional probabilities. These three events are not mutually exclusive events, mutually exclusive events, and independent events. In case of not mutually exclusive events, we need to take care of overlapping of event A and B. Finally, we have also discussed Bayes' theorem, which allows to update the probability of an event by incorporating new information. Now we close our session. Thank you for watching this video. Please send your feedback at t2@t2sir.com. Thank you.